Hey everyone, so I'm going to review parent functions. The first parent function that you guys learned was y equals x, which is a straight line. So y equals x. Y equals x has a domain and range of all real numbers. Now you could write that with the capital R like I just wrote that symbol, or you can write it as negative infinity, comma infinity. That means the same thing. Just as a reminder, what all real numbers means is that every value in the domain is working for, and in the range as well, is working for this function, meaning that you will always have a point. So if I took a trip on the x-axis, I would have a point down here, I'd have a point down here, here, here. And if I kept going, I would always hit a point. And the same thing goes for the range. If I started on the range, I would always have a point here, therefore I have all real numbers. The end behavior for this function is that as x goes to infinity, y also goes to infinity. Now, one way to help you out with this is to label the ends. This is an end, and this is an end. This end goes to infinity, and this one goes to negative infinity. So it should be simple now to do as x goes to negative infinity, because as x goes to negative infinity, it also goes to negative infinity, the y value. So I would say as x goes to negative infinity, y also goes to negative infinity. For the next function that you learned was the quadratic function, and the parent function for a quadratic is simply y equals x squared, and that is demonstrated to you on the right. The domain and the range for y equals x squared, the domain is all real numbers. And again, let me demonstrate this. I'm on the x-axis. I will always have a point. Even though I don't have one up here, you have to imagine that this graph continues up. So I will have a point here. I have a point here, I have a point here, I have a point here. So as I'm on the x-axis, I will always have a point that I can touch. So that's why my domain is all real numbers. But my range is a little tricky here because if you notice, the range is the y, and my graph only exists in the positive area of the range, meaning that it will never surpass the bottom portion below the x-axis. So my range will be y is greater than or equal to 0. Y is greater than or equal to 0. You could also write it like this, 0 comma infinity. The reason why we have a bracket here is because 0 is included, meaning that there is a point here at the origin. Now my end behavior for this is as x goes to infinity, y will do something. And again, like I said with the linear, label the ends. These ends both go to positive infinity. So x will go to infinity. Well, y will go to infinity. And as x goes to negative infinity, meaning like going to the left, y, in this case, if you go to the left, as x goes to the negative infinity values, y goes up to positive infinity. So that's why this goes to positive infinity. The next graph is cubic. You can kind of see it on the graph, but that's y equals x cubed. The domain and the range for this graph, they are both all real numbers, because when you take a trip on the x-axis, I will hit a point. Again, like the quadratic, this graph goes down forever. So it opens up wide. So meaning that this graph is opening up, and that's opening up like a wide, like a curtain. So when I do travel on the x-axis, I will hit a point down here. It might be far away, but I will be hitting a point, and I'll hit a point here and there and all the way up there, and so on and so forth. So my domain and range are all real numbers, and same thing with the range. I will always hit a point on when I'm on the y-axis. Now my end behavior for this is as x goes to infinity, y goes to something, and as x goes to negative infinity, y will do something else. And again, like the other graph, you can label the ends. This end is going to infinity, and this end is going to negative infinity. So as x goes to infinity, that's my first portion here, as x goes to infinity, y, so as x goes to infinity, y goes to infinity as well, because that's the right side of my graph. So I will put infinity here. And then as x goes to negative infinity, as I go this way on my graph goes down, so y goes to negative infinity. Exponential, the domain and range for an exponential graph. Well, let's analyze the domain. The domain in this case, if I took a trip on the x-axis, I would hit a point always. So my domain is all real numbers. My range, though, is a little tricky because if you notice the range, first off, it only exists in the positive y quadrants. Remember, range is your y. It only exists in the positive y quadrants. It does not go past the x-axis, kind of like the quadratic. But what's different about this one is because here we have a thing called an asymptote, which is kind of like a border that the graph will never surpass, meaning that I will never ever touch it or come in contact to it. Because of that, my range is always y is greater than 0. It could also be written as 0, comma, infinity, and I'm going to use a parenthesis with that 0 because I'm never going to touch the x-axis due to the asymptote that exists. And also, just a side note, which I didn't write here, the parent function for exponential is y equals b to the x. B can be any number. In this case, it's 2. On this graph, this is 2 to the x. So basically, this graph can be changed according to like what the b value is. Now my end behavior is as x goes to infinity, again y will do something, and I'm going to fill in the blanks. As x goes to negative infinity, y will do something as well. So as I go to the right, because this is the right side, as I look at the right, I'm going up to infinity. So I'm labeling that as infinity. As I go to the left on my graph, which is this portion here, my y value is going to 0. It's not going past this, so it's going to 0. Again, it's as x goes to a negative infinity, y will do something. So y goes to 0 in this case. The next graph is absolute value. Its parent function is y equals the absolute value of x, which is demonstrated to the right on this screen. So the domain and range for absolute value is very similar to the quadratic, just because it goes to the origin, just like the quadratic. The quadratic's U-shaped, absolute value is V-shaped, so the only really difference here is the shape of it. So my domain for this is all real numbers, and my range is 0 to infinity. Or you can say is y is greater than or equal to 0. My end behavior, well, both my ends for this graph, they both go to infinity, which is kind of simple now because all I have to say is as x goes to infinity, y will also go to infinity. And as x goes to negative infinity, y will also go to infinity, because they both end in the positive direction. Reciprocal, the graph for reciprocal is given off the equation y equals 1 over x. It is the reciprocal of y equals x, which is the linear equation. My domain and my range, you have to be careful with this one. So if I took a trip on the domain, if I'm on the x-axis, if I took a trip, I would see a point, I would see a point, I'd see a point, meaning that I'm seeing the graph, right now I'm seeing it below. But the problem is this area here. There is an asymptote here. So I'm going to put a dotted line there. But if I keep going on my domain, I still have points. I touch, I touch, I touch. So my domain is just that x can't be equal to 0. Now for my range, I have a similar scenario going on. If I took a trip on the y-axis, here I am, I will see a point, I will see a point, I will see a point, I will see a point. And then I get to this area here, and there's another issue here. There is an asymptote. I'm not going to make contact with anything here. So therefore, y can't be 0 or on the x-axis. Okay. Now my end behavior, as x goes to infinity, y will do something, and as x goes to negative infinity, y will also do something. Now the trick with this one is that there are like 4 ends of the graph, but you have to think of it as x goes to the right, which is this one, and as x goes to the left, which is that one. When you look at that as x goes to the right, it goes to 0. It goes to this asymptote here. And as x goes to the left, it also goes to 0, meaning the y value. The y value is going to 0, like it's leveling out at the 0. Remember, this equation here for the x-axis is y equals 0, so therefore I'm leveling out at the 0 value. So they both go to 0. The last parent function you learned was y equals the square root of x. My domain and my range of this graph are, my domain is, you take a trip on your x-axis. I don't see anything here. There's nothing over here, nothing in the negative x's, and that's because you can't put a negative in a radical, well, a square root specifically. So my first value I do have is here at the origin. I'm just going to put a point here so you guys can, believe me that there's a point there. So my domain is that x is greater than or equal to 0. Again, you could also write it like this. And my range is the same thing, except y is greater than or equal to 0. And that's because you can never output a negative number from a radical. And if you look at the graph, there is nothing down here. There's nothing below the x-axis. No y values can be negative, meaning that this is always going to be positive. My end behavior, again, I'm going to say as x goes to infinity, y does something. And then as x goes to, I need to leave this one blank. If you remember in class, that's a little bit of a special case. As x goes to infinity, meaning the right, as I go to the right of my graph, as I go to the right, I'm going up to infinity. So y goes to infinity. Now, for the left side of the graph, as I go to the left, I can't go to negative infinity. The only point I can go to is 0, 0. So as x goes to 0, because that's the last x value, y will also go to 0, which is the last y value on the graph. I hope this video helped you review parent functions, and I'll see you guys soon. Study up.